So what we're doing now is we're starting with 1 to 1000. As I told, not 2, until, sorry. As I told you, the value of this expression, which I wrote in brackets here now, is a stream. A stream is an object which is iterable. In Scala there is a different collection hierarchy than in Java. Of course you can use the Java collection hierarchy in Scala, you can use array list, everything that you know from Java, very fine. However, the collection hierarchy that Scala brings with it in its standard library is much more elaborated than the one from Java. And it offers you many more methods that are very useful. So what we want to do now with this stream is, step 1, we want to eliminate every numbers that are not multiples of 3 or 5. So we want to have another stream made on the basis of the stream 1 until 1000, where we filter only the numbers that are multiples of 3 or 5. The stream class, as every Scala collection class, supplies a method for that, which is called filter. And when called on a stream, it will return another stream in which only the elements are contained for which the filter is true. Now, of course, the filter method needs a way of determining which elements should go into the resulting stream. And this is the argument that we pass on to the stream. And this argument must be something that can be executed, must be a function, which receives an integer and returns a boolean. So, yeah, in Java you cannot do this, you cannot pass a function to something unless you define a special interface for that function with only one method. And that gets implemented by only one object that you will use. However, this produces very many lines of code which seem to be of no real use. So you don't program in this way in Java. I will now show you how to define a function that checks the numbers that should go into the filter. We call check. It has parameters. It has one parameter which is an integer, and it returns boolean. This is the way to declare the return type of a method in Scala. You will see that our main method has no return type. This is because it doesn't return anything. It's basically a void method when speaking in Java terms. In Scala the name is unit. It's basically the same as void in Java. So our check method returns a boolean. Now, if we were writing this like Java, we would do the following. An equal sign is missing here, because every method that returns something needs an equal sign before the curly brackets. You will see why in a few moments. And then we would write return I rest3 equals 0, or I rest5 equals 0. This is the Java way to do it. Use a return statement. However, in Scala you can do it differently. You don't need the return statement. You can declare this as the value of the function, like this. There you go. There are no need for curly brackets anymore. You don't need them when they are not necessary. There's no return statement because there's this equal sign which says whenever you want to call the method check, use this statement, and whatever the statement returns is the return value of the function. Now the compiler can know that the return value of check is a boolean, so we don't need to declare the type, because the type of this expression, the body of the function, is boolean. And when the compiler misses the type of the function here, it will try to find out and guess on its own. And when that doesn't work, the compiler will complain. However, in this very simple case, it works. Now we have a function called check, which will return a boolean when given an integer. One thing that might astound you is that I included the method check inside the body of the main method. This is again something that you cannot do in Java. In Java you cannot define a function inside a method. It's impossible. In Scala you can do so very easily, and this is useful for methods that are used only inside one other method and not outside of it. It's also invisible to the rest of the world. There's no way to declare it public or provide it to the rest of the world just like this. It's only known to the main method. Now what we want to do is we want to pass on the check method itself to the filter method as a parameter. So the filter method can use the check method in order to check all the numbers. We can do this by writing down the name of the check method. However, the compiler, when it sees that we use the name of a method, will believe that we want to invoke that method, because that's what you usually do with methods. We need to tell the compiler that in this case we don't want to invoke it. We want to refer to the method itself. And this is by putting an underscore behind it, separated with a space. Otherwise the underscore would be part of the method name, obviously. Now the compiler knows we want to pass the check method itself to the filter method and not call the check method right now. This is another thing that you can't do in Java. In Java you cannot take the method of an object and just pass it on to somebody else who can then call it. You can do it via reflection in Java. However, this is not very easy. Not a very good way to do it, so you won't even think of doing this in Java. In Scala you will find yourself thinking on the terms much more often, because it's so easy to do. Okay, so what do we have now? We now have a stream of numbers which contain only the multiples of 3 or 5. What we want to do now is build a sum. We want to add all of them. There is something in Scala called folding, the fold left and fold right methods. You can look them up, they are very interesting. This would usually be the way to do it. However, in Scala 2.8, which is as of now the current version of Scala, they provided a new method for all collection types, which is sum, and this builds the sum. You can only use the sum method when it's a collection of something that can be added. And the result of this we want to print out. There's no reason to have a variable called sum anymore, so we just print out that statement. I'm compiling this right now. I'm hoping that I made no mistakes. Yep, the compiler is happy, and so let's run our neat program. There you go. Again, it's the correct solution. Yeah. There's one more thing we can do. Although I've gone into great length to tell you that we can declare the check method as part of the main method, and it's all very funny, we don't really need the check method. Look at the code. We only use it once. So it's kind of a waste to assign a name to it and make it a reusable method that can be used several times inside the main method. We only use it once, so it would be fair if we could declare it right there where we need it, just in place. And you know, anonymous classes in Java, there is something like an anonymous function in Scala, which you can define in place, doesn't have a name, can be used only once. Of course you can assign it to a variable if you want to. And so we can first remove the check method, because I will show you how we go without it. Then we can of course remove the use of the check method, and for declaring anonymous functions you use curly brackets, and still when you use those curly brackets the compiler cannot be sure that at this point you want to declare an anonymous function. The compiler needs some more information, so there's a special syntax for defining anonymous functions which the compiler can recognize, and this is that. First comes the parameter list, which I will leave empty for now. Then comes this arrow with an equal sign, and then comes the body of the anonymous function. So the parameter which we have here is an integer. I'm sorry, this was the automatic code completion. It guessed wrong. Yeah, now we have one parameter in brackets I int, and of course the body should be I rest3 equals 0 or I rest5 equals 0. Yeah, now this would work. This is the most verbose way to write this down. In many cases you can leave out parts of the syntax and the compiler will still be smart enough to recognize it. In case of doubt, when the compiler cannot recognize it for more complicated anonymous functions, this is the syntax that you might want to write it down, because there can be no ambiguities here. However, if you have only one parameter, we can leave out those braces. If you have more than one parameter, you need them. I think this is because the look ahead of the compiler is limited. And now the structure of this anonymous function is so simple that we can even leave out the curly brackets in this case. I cannot give you a real... I'm sorry. Yeah, in this case we also have to leave out the... I'm trying to say too much at the same time. We can leave out the curly brackets at this time. I cannot give you a real rule for when you can leave out the curly brackets and when you can't. I'm personally always trying to compile, and I will see if the compiler has a problem or not, and if the compiler has a problem I put the curly brackets in place, and there you go. In this case we can even leave out the type of I, because the compiler knows what the filter method expects. The filter method needs something which takes an integer parameter, so it knows that the first and only argument of the anonymous function must be of type integer. Yeah. And as you've seen, when we write it there, we get already some squiggly red lines there, which shows that there's some problem with the syntax. It seems that the colon already makes it unambiguous. So you would have to use the curly brackets if you were to declare the type explicitly of I, but we can leave it out, and so the compiler knows again what we mean. I will compile the whole thing now, and I hope it works. Yeah, it worked, and now let's run it. There you go. Correct solution. So this is the final version of our program. It has become very short over time. There is no lot of information compressed into one single line. However, when you're used to programming Scala, you will recognize very easily the meaning of the line, probably even easier than the several lines that you would write when you would write Java code. You will get used to this very fast, and I think the syntax is, if you know the basics, it's quite easy to see what this line does. There are a lot of things that I left out here. Some things I went through rather fast. You might want to look up some tutorials yourself. I will try to continue with the next Euler problems in the next tutorials. I don't know how many I will make. It depends partly on the feedback that I get. If you like this tutorial, you might want to leave some comment to motivate me to make more. I hope this was nice for you. I wish you a nice day, and see you